Hi, my name is Chang. I'm here to present our work on UnZipLoRA separating style and content from a single image. The central challenge we want to address is concept decomposition from single input image, which contains both a unique subject and a style. Our core goal is to decompose the input into its constituent, content LoRA and style LoRA, which could be used for personalized generation. They can also be applied for complex recontextualization, meaning that these LoRAs could be used for generating completely new scene controlled by prompt, while preserving the original concepts. Although currently there are many powerful personalization tools like the famous DreamBooth, they suffer from a key limitation. They cannot easily perform this disentanglement of content and style. If we directly use DreamBooth, as we shown, the content and style are still entangled. That's why we introduced UnZipLoRA to solve this disentanglement issue. The overall structure is shown here. Our method works on diffuser model SDXL. We will train a content LoRa WC and a style LoRa WS. We will also train another column with MC and MS. With single input image and its correspondence prompts, we will train those four things all together. To solve this problem, we have three contributions, which are prompt separation, column separation, and block separation. After training, the two LoRAs could be either used for content recontextualization or the style recontextualizations. The two LoRAs can also be used all together and have a merged recontextualization with both content and style. Prompt separation is that we design different prompts for content and style. During training, instead of simply use one prompt, we feed different prompts for backbone and LoRAs. These techniques help separating two LoRAs better. For example, if we simply use DreamBooth the baseline, the content and style are not separated and the two LoRAs cannot be merged. That is because the two LoRAs are trained differently, making them be conflict with each other. After we add prompt separation, for content, it is totally destylized, while for style, it is also much better. However, there are still some problems with prompt separation. First, the details of content and style are not totally captured. More severely, for merge generation, although the two LoRAs could merge, but they cannot do a flexible recontextualizations. To solve this issue, we introduce column separation. It is found that a small subset of feature columns in LoRA is enough for capturing concepts. Therefore, we apply sparse column weights for content and style. Also, from our previous research ZipLoRA, we try to keep the column weight complementary to help better disentanglement. Finally, we use block separation to maximize fine-grained details capturing. Inspired by previous work, we designed a fine-grained split showing this figure for better details preservation by using different blocks in UNet during joint training. With the help of those two techniques, the previous problems of prompt separation could be solved. Seeing this example, after we apply column and block separation, we find that the details of the content are better reserved, and the style is exactly the same as the input. For the merge generation, now it could merge together and do a perfect recontextualization, meaning that our goal is all achieved. Here are some results of our method. First, we show the comparison between ours with inspiration tree. Inspiration tree is designed for extracting concepts from given images. However, with the stylized input, it fails to preserve its features like the microscope and the geometry style, and it could not do a merge. While in our method, we could both extract the concepts, preserve the details of the microscope, and do a perfect recontextualizations for merge generation. We also show comparison between ours and B-LoRA, which is specifically designed for extracting content or style from images and combine them together. Although they can separate the content and style, their data is distorted, and their combined generation it is of poor quality. We outperform them by having a totally destylized data in content generation and a better recontextualization. We also show a user study calculating the preference of UnZipLoRA over other methods. It is obvious that From these user studies, most users believe UnZipLoRA outperforms other methods. We also showed some other applications more than recontextualizations. Our methods could combine the concepts from two different images. For example, if we have one group of subject input and another group of style input, we could combine them all together, like we've shown here. This shows that our method could do a very flexible combination of different kinds of concepts. That's all I want to present. Feel free to check our webpage for more results. Thank you.